Good morning, students. The previous videos we have discussed the partial fractions in full. So, and we have covered exercise 7a, 7b, 7c and 7d. So, if you do not understand the concept, then this particular video is for you. So, in this actually we will be discussing the examples of all the exercises 7a, 7b, 7c, 7d. Not only that, actually a small explanation is also will be provided. So first of all, a polynomial is of this form: f of x is equals to a0 x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus etc. plus an, where a0, a1, a2, etc. an are said to be the coefficients which are real numbers, with a0 not equals to 0 is said to be the polynomial in x, with the highest power or exponent is said to be the degree. So this is the nth degree polynomial. So the examples for which is x power 4 minus 1, x cube minus 3x square plus 2x plus 1. So x square minus 3x plus 2, x minus 1, etc. This is the biquadratic polynomial with the degree 4. This is the cubic polynomial with the degree 3. And this is the quadratic polynomial with the degree 2. And this is the linear polynomial. This particular linear polynomial contains two terms. So therefore, a linear polynomial is having at most two terms with the degree 1, with its quotient 1, which is not equals to 0. So, and a quadratic polynomial is having at most three terms. Not only that, x square minus 2, this is also a quadratic polynomial. X term is absent here. This is also said to be the quadratic polynomial. Not only that, simply 2x square, this is also a quadratic polynomial with the x term and constants are missing. So that is why at most 3. So with the degree 2, etc. And after that, polynomial. So we have fraction. So if f of x and g of x are two polynomials, then f of x by g of x is said to be a rational fraction, or simply fraction. So for example, 3x square minus 2x plus 1 by x power 4 minus 1 is an example for a rational fraction. Okay, and in this rational fraction, proper fraction, improper fraction. So, a fraction in which the degree of f of x is less than that of degree of g of x, then that kind of a fraction is said to be a proper fraction. For example, x by x minus 1 into x minus 2, or 2x minus 3 by x minus 1 into x minus 2. This is a proper fraction because the degree of the numerator is 1 and degree of denominator is 2. Improper fraction, degree of f of x is greater than or equals to degree of g of x. So the example for which is 2x square by x minus 1 into x minus 2. So here degree of both numerator as well as denominator is the same, 2. Or even this is x cube by x minus 1 into x minus 2. So this is also an improper fraction. Now, after this, we have discussed reducible polynomial and irreducible polynomial. A polynomial which can be expressed into the product of two polynomials, then it is said to be reducible polynomial. So for example, x cube minus 1, this is a cubic polynomial but this can be expressed as x minus 1 into x square plus x plus 1. So this polynomial can be further expressed as the product of two polynomials, x minus 1 and x square plus x plus 1. So this is said to be the reducible polynomial. So x square minus 9, this is x plus 3 into x minus 3. This is also an example for a reducible polynomial, but x square plus 1, of course it can also be expressed as x plus 1i into x minus 1i. So it is expressed as the complex factors, but it cannot be expressed as the real factors. Therefore, it is said to be an irreducible polynomial. So here, this is our form ax square plus bx plus c with a not equals to 0 and b square minus 4ac is less than 0. A polynomial is said to be an irreducible polynomial if b square minus 4ac, its discriminant is less than 0. So here the discriminant is b square is absent here, 0 minus 4ac, 4 1 to 4. So minus 4 is obviously less than 0. Therefore it is said to be irreducible polynomials. So, and expressing a proper fraction into the sum of proper fractions is said to be resolving into partial fractions. We are having the 4 types to resolve the given proper fraction into the partial fractions. Type 1 says, first of all, f of x by g of x is a fraction in which g of x not equals to 0 and the degree of f of x is less than degree of g of x. That means it is proper fraction. So type 1 says, if the denominator contains non-repeated linear factor, g of x contains non-repeated linear factor. So for each ax plus b, which is a linear factor, for each linear factor of ax plus b of g of x, there exists a partial fraction of the form a by ax plus b. For example, x by x minus 1 into x minus 2. First of all, this is a proper fraction. So here, degree of numerator is 1 and degree of denominator is 2. So degree of f of x is less than degree of g of x. Here, this is the form ax plus b. This is non-repeated. So, had it been x minus 1 whole square, it is said to be a repeated linear factor. Whole cube, repeated linear factor. But here, it is of the form ax plus b, which is not repeated. For every non-repeated linear factor, there corresponds to a partial fraction of the form a by ax plus b. So, there are two non-repeated linear factors for which we have to take two constants. A by x minus 1 plus b by x minus 2, and a and b are to be evaluated. So type 2 says g of x contains repeated linear factor. So for every linear factor of ax plus b, there exists a partial fraction of the form a by ax plus b by ax plus b whole square plus c by ax plus b whole cube. If there are n factors of ax plus b, there would be n number of ax plus b whole power n. So this is a1, a2, a3, etc. This is an. So for example, 2x minus 1 by x minus 1 whole square into x minus 3 whole square. So here, this is the form ax plus b whole square. This is a repeated linear factor. So for every repeated linear factor, that corresponds to a by ax plus b, which is x minus 1, plus b by x minus 1 whole square, plus c by x minus 3, plus d by x minus 3 whole square, and so on. Here a, b, c and d are to be evaluated. Here x equals to 1, x equals to 3 has to be substituted, and among 4 we will be getting any two constants. The remaining two constants will be get through the comparing coefficients on both sides. Third one, g of x contains non-repeated irreducible quadratic factor. So for every non-repeated irreducible quadratic factor of ax square plus bx plus c, there exists a partial fraction of the form ax plus b by ax square plus bx plus c. Example, x minus 1 by x square minus 3x plus 3. So this is a proper fraction with degree of f of x is 1, degree of denominator is 2. So 1 is obviously less than 2, and this is of the form ax square plus bx plus c. So if you find b square minus 4ax, the discriminant, then actually we will be getting 9 minus 4 3 is 12. So 9 minus 12 minus 3 not less than 0. Therefore, it doesn't have real roots. Therefore, it is said to be irreducible quadratic factor. For every irreducible quadratic factor, there corresponds to a partial fraction of the form ax plus b by x square minus 3x plus b, and a and b are to be evaluated. And the type 4 says, for every g of x contains repeated irreducible quadratic factor. For a repeated reducible quadratic factor of ax square plus bx plus c, there corresponds to partial fractions of the form ax plus b by ax square plus bx plus c, cx plus d by x square plus bx plus c whole square, etc. For example, x minus 1 by x square minus 3x plus 3 whole square is, this is ax plus b by x square minus 3x plus 3, cx plus d by x square minus 3x plus 3 whole square, and so on. So here a, b, c, d are to be evaluated. So these 4 types are for proper fraction. So what if the improper fraction is given and we are asked to find out the partial fractions for that? So improper fraction. So division algorithm which we have used for natural numbers is applicable for this polynomials also. Says that if f of x, g of x are two polynomials, then there exists polynomials q of x and r of x such that f of x is equals to q of x into g of x plus r of x, where either r of x is equals to 0, remainder is 0, or degree of r of x denominator is less than degree of the divisor, degree of g of x. So here there will be two cases arise. Degree of f of x is greater than degree of g of x, or degree of f of x is equals to degree of g of x. So here f of x is equals to q of x into g of x plus r of x. So dividing by g of x on both sides, then we'll get q of x plus r of x by g of x. So here we leave this q of x aside, and here r of x by g of x. So it will automatically convert it into a partial fraction, and we know how to resolve this proper fraction into the sum of partial fractions using the methods which we have discussed right now, type 1, type 2, type 3 and type 4. So, but as far as degree of f of x is equals to degree of g of x is concerned, we will be getting f of x by g of x is equals to k plus r of x by g of x, where k is the coefficient of the highest degree terms in f of x and g of x. So the examples are for 4 by. So here this is a rational polynomial. So with the f of x and g of x both are polynomials, and degree of f of x is 4 and degree of g of x is 2. So degree of f of x is greater than degree of g of x. Therefore, division algorithm, so type 1 here, case 1 is applicable here. So it says that we have to divide this x power 4 using the denominator, which is x square minus 3x plus 2. So this is x square x power 4 minus 3x cube plus 2x square. So this is minus plus minus, I am subtracting 3x cube minus 2x square. So further division is possible or not. So we have to stop this process when we get the degree of this is less than the divisor. But here it is not the case. Here the degree of remainder that we get right now is greater than that of degree of g of x. Therefore further division is possible. 3x cube by x square, 3x times. So 3x into x square. So 3x cube plus into minus minus 3 3s are 9x square, 3 2s are 6x. So minus plus minus. So 9x square minus 2x square is 7x square minus 6x. So here degree of remainder and degree of the divisor both are equal. So we should not compromise. So we have to divide further. So we have to stop this process when degree of this remainder is less than degree of the divisor. So 7x square by x square, which is 7. So 7 into x square, 7x square. 7 3s are 21x. 7 2s are 14. So minus plus minus 21 minus 6 is 15x minus 14. Now you compare this degree. Degree of this remainder is 1. Degree of g of x is 2. Therefore we have to stop. Now this is equals to x power 4 is equals to, this is g of x, this is of x. So this is equals to x square plus 3x plus 7. This is x power 4 by x square minus 3x plus 2 is equals to q plus R is which is 15x minus 14 by x square minus 3x plus 2. So we have to keep this apart, and 15x minus 14 by x square minus 3x plus 2, which is a proper fraction with the degree of numerator is 1 and degree of denominator is 2. Therefore, the partial fractions is applicable for this proper fraction. So this is x minus 1 into x minus 2. So 15x minus 14 by x minus 1 into x minus 2 is equals to a by x minus 1 plus b by x minus 2. So a and b are to be evaluated. So whatever we get, so this is to be added, will be the final answer for that. Now, what if degree of numerator and degree of denominator is the same? For example, this is x square by x minus 1 into x minus 2. So here we need to divide in that case also. X square minus 3x plus 2. X minus 1 into x minus 2 is x square minus 3x plus 2. X square. So x square by x square is 1. So 1 into x square. So minus 3x square minus 3x plus 2. So this is minus plus minus. So 3x minus 2. So this is equals to x square by x square minus 3x plus 2 is equals to 1 plus 3x minus 2 by x square minus 3x plus 2. So here also the division algorithm method is applicable, but instead of doing all these things, the shortcut is, so here what is the degree of the highest degree term in the numerator? X square. So x square quotient is 1 here by here x square minus 3x plus 2. What is the degree of the highest term in the denominator? X square quotient is here 1. So 1 plus. So now how do we take the partial fractions for this? A by x minus 1 plus b by x minus 2. So this you take the LCM and comparing on both sides and equate, then actually a and b values we will get. Now the last one is conversion of f of x by g of x in power series of x. In that actually we will be using 1 minus x whole power minus 1, 1 minus x whole power 1, 1 plus x whole power minus 1, 1 minus x whole power minus 2, 1 plus x whole power minus 2, etc. are said to be the power expansions, and these power expansions are useful to find the proper fractions of the power series of x. So this is 1 plus x square plus x cube plus etc. plus the general term is x power k plus etc. So this is 1 minus x plus x square minus x cube plus etc. plus minus 1 whole power k into x power k etc. So this is 1 plus 2x plus 3x square plus 4x cube plus etc. plus k plus 1 into x power k plus and so on. So this is equals to 1 minus 2x plus 3x square minus 4x cube plus etc. plus minus 1 whole power k into k plus 1 into x power k plus etc. So these are the power series expansions. So with the help of this, we will solve the last exercise. Let us discuss these examples from the textbook. So 5x plus 1 by x plus 2 into x minus 1. First of all, this is a proper fraction, and the denominator contains two non-repeated linear factors. So type 1. So 5x plus 1 by x plus 2 into x minus 1 is, since it contains two non-repeated linear factors, therefore we have to take two constants, a by x plus 2 plus b by x minus 1. So on taking LCM, we'll get x plus 2 into x minus 1. So this is a into x minus 1 plus b into x plus 2 by is equals to 5x plus 1 by x plus 2 into x minus 1. So these two get cancelled. So 5x plus 1 is equals to a into x minus 1 plus b into x plus 2. Now, x plus 2 and x minus 1 are the two linear factors. Equate them to 0. X equals to 1 and x equals to minus 2 are the roots or solutions. So, if it is a root, it has to satisfy the equation. So, put x is equals to 1. 5 on the 5 plus 1 6 is equals to 1 minus 1. On substituting 1 here, it will be 0. So, b into 1 plus 2 is 3. So, from this, b is equals to 6 by 3, which is 2. Now, put that x is equals to minus 2. So, 5 into minus 2 minus 10 plus 1 minus 9 is equals to. On substituting this minus 2 here, it will be 0. So, a into minus 2 minus 1 is minus 3. So, from this, a is equals to 9 by 3, which is 3. Therefore, 5x plus 1 by x plus 2 into x minus 1 is equals to, the value of a here is 3 by x plus 2 plus b value is 2 by x minus 1. So this is how we will solve. And the second one is 2x plus 3 by 5 into x plus 2 into 2x plus 1. So here also the denominator contains two non-repeated linear factors. So a by x plus 2 plus b by 2x plus 1 into, so actually this is 2x plus 3 by x plus 2 into 2x plus 1. The partial fractions for which is this. Into here 1 by 5 is there. So 1 by 5 into 1 by 5 I have separated from the process of these partial fractions. So now for 2x plus 3 by x plus 2 into 2x plus 1, this is the partial fractions. Now this is equals to 2x plus 3 by 5 into x plus 2 into 2x plus 1 is equals to 1 by 5 into, this is x plus 2 into 2x plus 1 or the is the LCM. So a into 2x plus 1 plus b into x plus 2. So 5 on both the sides gets cancelled and this also on both the sides gets cancelled. So this is equals to 2x plus 3 is equals to a into 2x plus 1 plus b into x plus 2. So put x is equals to minus 2. So 2 into minus 2 minus 4 plus 3 minus 1 equals to. So 2 into minus 2 is minus 4 plus 1. So minus 3a. So a is equals to 1 by 3. So put x is equals to minus 1 by 2. 2x plus 1 equals to 0. 2x equals to minus 1. X equals to minus 1 by 2. Now 2 into minus 1 by 2. 2 gets cancelled. Minus 1 plus 3 is 2. So 2 into minus 1 by 2. 2 gets cancelled. Minus 1 plus 1. This is 0. So b into, this is minus 1 by 2 plus 2. 2 2s are 4. Plus 4 minus 1 is 3 by 2. So from this b is equals to 2 2s are 4. 4 by 3. Therefore 2x plus 3 by 5 into x plus 2 into 2x plus 1 is equals to 1 by 5 into a value is 1 by 3 by x plus 2. 1 by 3 into x plus 2 plus the value of b is 4 by 3. So 4 by 3 into 2x plus 1. So this is equals to 1 by 5 3s of 15 into x plus 2 plus 4 by 3 5s of 15 into 2x plus 1. So this is how we will resolve. So the third question is 13x plus 43 by 2x square plus 17x plus 30. Most of the students do this problem wrong, because since this denominator contains quadratic factor, so they will jump to the type 3 and they will take this as ax plus b by 2x square plus 17x plus 30, and they will evaluate a and b. So which is a wrong process, because this is a quadratic factor, okay, but which kind of a quadratic factor it is? Is it a reducible quadratic factor or irreducible quadratic factor is what we have to check first. So type 3 says for every non-repeated irreducible quadratic factor, there corresponds to a partial fraction of the form ax plus b by ax square plus bx plus c. But here we have to see whether this is a irreducible or not. So here b square minus 4ac, so 17 square 389, so minus 230s, so 329, which is positive, it's not a negative. If b square minus 4ac is less than 0, then it is said to be irreducible quadratic factor, but here it has the factors. So first of all we need to find the factors for them. 2x square plus 17x plus 30 is equals to 2 into 30 60, and 12 5 is 60, 12 plus 5 is 17. So 2x square plus 12x plus 5x plus 30. So take 2x in common, x plus 6, take 5 in common, x plus 6. So x plus 6 if you take common, this is 2x plus 5. Therefore 13x plus 43 by 2x square plus 17x plus 30 is equals to, which is a wrong one, as I said before. So here this is 13x plus 43 by 2x plus 5 into x plus 6. So the partial fraction for this is a by 2x plus 5 plus b by x plus 6. And it is not wrong if you take first this is x plus 6 and this is 2x plus 5, then a by x plus 6 plus b by 2x plus 5. The answer would be the same. So this is equals to 13x plus 43 by 2x square plus 17x plus 30 equals to, the LCM is 2x plus 5 into x plus 6. So a into x plus 6 plus b into 2x plus 5. So these two gets cancelled on both the sides. Put x is equals to minus 6, because x plus c is the factor, x equals to minus 6 is the root. So substitute 13 into 6 minus 78 plus 43 is equals to b into 2 into minus 6 minus 12. Minus 12 plus 5 is 7. This is equals to 8 minus 3 is 5. So minus 7 plus 4, 7 minus 4 is 3. So minus 35 equals to 7b. Therefore, b is equals to minus 35 by 7 is minus 5. And so put x is equals to minus 5 by 2. Then we'll get 13 into the value of x is minus 5 by 2 plus 43 is equals to a into the value of x is minus 5 by 2 plus 6. On substituting minus 5 by 2 here, so 2 into minus 5 by 2, 2 gets cancelled, minus 5 plus 5 0, into this is 0. So this is equals to minus 13 5s are minus 65 by 2 plus 43 is equals to a into minus 5 plus 2 6 are 12. 12 minus 5 is 7 by 2. This is equals to 2 3s are 6, 2 4s are 8 minus 65 plus by 2 is equals to 7a by 2. So these 2 gets cancelled. So 6 minus 5 is 1. 8 minus 6 is 2. So 21 by 7 is equals to a. Therefore, the value of a is equals to 3. Therefore, the required partial fraction for this is a by a is equals to 3. 3 by 2x plus 5 plus b value is minus 5. So minus 5 by x plus 6. So this is the partial fraction for this given proper fraction. X square plus 5x plus 7 by x minus 3 whole cube. So here the denominator contains repeated linear factor, repeated thrice. So for every repeated linear factor of ax plus b whole power n, there corresponds to partial fractions of the form a1 by ax plus b, a2 by ax plus b whole square, a3 by ax plus b whole cube, etc. an by ax plus b whole power n. So here instead of a1, a2, a3, etc. an, we will be taking a, b, c, etc. Since the problem is limited, finite number of terms will be given, for which instead of a1, a2, a3, etc., we will be taking a, b, c, etc. So here this is a by x minus 3 plus b by x minus 3 whole square plus c by x minus 3 whole cube. So the LCM is x minus 3 whole cube. So this is a into x minus 3 whole square, x minus 3 whole cube by x minus 3 whole square times into a. So plus 3 into x minus 3 whole cube by x minus 3 whole square, x minus 3 times into b. So b into x minus 3 plus c into this gets cancelled, we get plus c is equals to x square plus 5x plus 7 by x minus 3 whole cube. These two gets cancelled on both. So 3 square 9, 9 plus 7 16, 5 3s are 15, 16 plus 15 is 31. So this gets cancelled because 3 minus 3 is 0, 3 minus 3 is 0. So c is equals to 31 directly we will get that. Now to get the remaining constants, so we have to compare the coefficients. So comparing coefficients of x square on both sides. Here x square quotient is 1. Here x square quotient is a. So a is equals to 1 we get. And comparing coefficient of x on both sides. So here x quotient is 5. Here x square minus 3x a square plus b square 9 minus 2 3s are 6x. So x quotient is minus 6a here plus here x quotient is b. So this is equals to 5 is equals to minus 6 1s are 6 minus 6 plus b. Therefore b is equals to 5 plus 6 which is 11. So therefore x square minus plus 5x plus 7 by x minus 3 whole cube is equals to the value of a is 1 by x minus 3 plus b value is 11 by x minus 3 whole square plus c value is equals to 31 by x minus 3 whole cube. And we also have an alternative to solve this problem easily. So, and this alternative is useful if the denominator contains the only repeated linear factor. So here x minus 3 is the only repeated linear factor. What I'm trying to say is, along with x minus 3 whole cube, so it should not be another linear factor which is a repeated or non-repeated linear factor. So it should not be associated with x minus 2 or x minus 2 whole square, etc. It should be a unique repeated linear factor. So for this, x minus 3 equals to y, we will take x equals to y plus 3. So here the x value can be replaced as y plus 3 whole square plus 5 into the value of x is y plus 3 plus 7y. X minus 3 is y cube. So this is y square, 3 square 9 plus 2 3 is 6y. So 5y, 5 3 is 15 plus 7y, y cube. So y square plus 6y plus 5y is 11y. 15 plus 7, 22 plus 9 is 31 by y cube. So a plus b plus c by d, a by d plus b by d plus c by d. So y square by y cube is 1 by y. So 11 by y cube is 11 by y square plus 31 by y cube. Now replace y by x minus 3 which we have got earlier. So 1 by x minus 3 plus 11 by x minus 3 whole square plus 31 by x minus 3 whole cube, and you may check with the earlier answer.